Okay, today in section 2.6 we're going to be talking about phase shift. Previously we worked with amplitude, periods, and we also did some reflections. Today we're going to add in the phase shift so we can see that our general formula is extending itself a bit to something that looks like this. So let's just practice with working a problem and having a method and a procedure to be able to work these kind of problems and get a graph of these functions. So our first one is going to be graph y equals 3 sine 2x minus pi. Okay, so the first thing I want you to do is I want you to pause this and label your amplitude, your period, and your phase shift using these formulas right here. Okay, good. So I put the formula underneath it just so we can see there is no horizontal shift going on here because we don't have that beta value, but the rest of it we can determine. So our amplitude is 3, our period ends up being pi, and our phase shift is shifted pi halves units. Okay, and just to try to make this into a step or something that's a little bit procedural to follow, for these we're going to start at the phase shift because we have things going on. First of all, we have it shifting, and then we also either have it squished up or stretched out. So there's a lot going on, and sometimes it can be confusing. So if we start at the phase shift, which in this case is going to be pi over 2, add a period of pi, that gives us our start and our end. Okay, so if we have our start and our end, then we can just divide the period to get equal subintervals like we did in the last lesson to be able to find the particular points we need to get a good sketch of this graph. So let's do that on the next page. Okay, so if we start at pi over 2, which this is our phase shift right here, we add our period to it. We're going to end at 3 pi over 2. So basically this is the idea. Now we want to have points in between so that we can go to a XY table and be able to fill those out. So we're going to start at pi over 2, start with our period, excuse me, and divide it into 4 equal parts. Okay, so here you can see we have it set up. The step 2 is to have our period divided into equal parts. So we end up having pi fourths. So each of the increments will be pi fourths. So I start here at my phase shift. I'm going to add pi fourths to get this value, add pi fourths to get this value, add pi fourths to get this value, so on and so forth. So pause it and plug those values in. Okay, good. You can see where we have our scratch work here to get to 3 pi fourths to pi to 5 pi fourths. Now we're ready to go set up our table and actually plug our values in to find an ordered pair. Let's go to the next page. Okay, so here you can see we're just going to set up a table. We have our function that we're graphing. We have our particular x values that we've incremented out. And all I've done is plugged in the place of x equals pi halves, 3 pi fourths, and set this up. So what I want you to do now is take your time. We'll work through one of these together, 1 or 2 of these together, and then I'll give you a few minutes to let you continue on. So let's say if we have, first of all, we want to do order of operations here, and we need to simplify these 2's, right? So then this 2 will cancel with this 2, and you're just going to have pi. I'm going to write every step in this one. So 3 sine of pi minus pi here, okay, which that would then give us 3 times the sine of 0, right? What is the sine of 0? So you go to 0 and the sine is the y value, right? So what is the sine at 0? 0, good. Let me move that. So this is just 0, and then we multiply that times 3, so 3 times 0 is 0. So our ordered pair would be when x is pi halves, y is 0. Okay, let's do one more together, and then we'll check our work on the others. So we have 3 times the sine of here, 2 fourths is going to simplify. So, or you can say 2 times 3 is 6 over 4 and reduce that. However you prefer to deal with multiplying fractions there is fine, but that's going to be 3 pi over 2 minus pi Okay, so that's just going to be 3 times the sine of 3 pi over 2 minus pi. If you've got a common denominator, that would just give us pi over 2. All right, let's pull this up. Sine at pi over 2. So we go to pi over 2. What's the y value at pi over 2? 1. Good. So I will put 1 here. And then, of course, we drop down to 3. Order of operations. 3 times 1 is 3. So the ordered pair when x is 3 pi fourths. Let me see if I can make that a little neater. When x is 3 pi fourths, y is 3. Okay? So I'm going to pause this and go ahead and fill out the rest of this table. I'll let you do the same, and then I want you to check your work. And the last thing we'll do is graph this. Okay, so plugging our values in, you want to check your work right there. Now we have our 5 ordered pairs, so we're going to take these on to the next page and plot them on a graph and get our sketch. Okay, so we just sketched an XY table. We have -3 and +3 because our amplitude is 3. We start at pi over 2. Remember, we end at 3 pi over 2, and these were our equal increments. And then along the bottom, I just put our ordered pairs that we calculated. So let's go ahead and sketch those. So you go over x value of pi over 2, y value of 0. Let's put an ordered pair there. 3 pi over 4, comma 3. What I have is up here. Pi 0, 5 pi fourths, -3, 3 pi over 2, 0. Let's try to do a good job sketching that. And there we go. That is our y equals 3 sine 2x minus pi. Okay, before we go on to do some more examples like our previous method, I want to just show you a method using transformations, so that sometimes you would just be able to look at an equation and be able to have an idea of what's going on. This is what we're familiar with. This is what we've been using. Of course, the plus beta is not there because we don't have a vertical shift going on, but we just have, this is what we're familiar with, this is what we looked at last time. For a transformation, it needs to be in this format. So let's just take the example we had from the last lesson. So if I had, or a example, so let's say I gave you y equals 3 sine of 2x minus pi. Okay? Yeah, that's the exact same one we just did. So this is the format that we were familiar with. Now we need to make this fit into this format. So let's work on doing that. So to do that, we would have y is equal to 3 sine. Okay, we would pull the 2 out and we would just have x by itself. Now if that's the case, we're just going to have pi, which is still our phi. Phi is pi, right? So pi over what's omega? 2. Good. Okay, now what that allows us to do is that allows us to just separate things so that we can see we have an amplitude here, and we have, if you remember transformations back from college algebra, when you have in this parenthesis right here, that's going to tell you it's shifted to the right 4 unit, to the right pi halves units. Excuse me. Pi half units. Okay, so let's see what that happens. Basically, it's a sine graph, amplitude 3, but we picked it up, instead of being at 0, 0, we picked it up, moved it to the right pi halves units, and then it's the same exact pi graph. And we kind of talked about that at the beginning of class a little bit. So basically, this idea right here, if we convert our equations over to this format, it allows us to see right here in this parenthesis exactly what the shift's going on. So if this was a, let's just say I have the same equation, let me throw another example at you. So if I had 3 sine of 2x plus pi fourths, right there, we could say, we can see this part's isolated. This would be shifted to the left pi fourths unit. So basically we'd be picking that graph up graph up and to the left. So anyway, that's just a food for thought for some of your multiple choice types questions. If you understand transformations and you remember those, that's something that you could also use. Okay, so now we're going to go on with some more examples using our method of choice that's been consistent for all of our problems. So we're going to do some more examples like that.